And I see the clickbait title actually worked. Very nice. So I don't see a lot of people in the back, but let's try anyway. So who's a Java developer? Wow, love that. What are the other programming languages, like Perl? Okay. PHP? 1, 2. Psst. Python? Okay. No JavaScript? No JavaScript. Okay, normally it's like, you actually broke the joke. Normally it's like Python, well, everything is okay as long as it's not JavaScript, but it didn't work out this time. Okay, fair enough. So, the Stateless Microservices Hoax. I think that's a little bit of a mean title, isn't it? So who agrees that this is mean? Who actually thinks that microservices can be stateless? Well, okay, fair enough. Let's see if we can get some nice discussion around that afterwards. So let's start with a disclaimer, right? Because everything needs a good disclaimer. I don't consider myself a microservice expert, so correct me if I'm wrong, and I hope I am. So I just try to do something, and that means I'm looking forward to a lot of discussion afterwards. I just finished the slide deck yesterday, and I think it's about 40 to 45 minutes. I guess it's normally like an hour, so we have plenty of time for discussions. But please, in the end, right, after I kind of demoralized all of you, right, because we don't want to start early. Okay, so who I am. I normally go with the name Chris. My official name is Christoph. That works in Germany, it works in Austria, in Switzerland, and a couple of other countries. I figured out it doesn't work in Asian countries. Even in the US, some people have problems with that, but they all know Chris. So Chris is what I normally consider to be called. I'm working for Hazelcast as Manager of Developer Relations. For everybody who didn't realize it yet, yes, that is a commercial t-shirt. It says Hazelcast in the middle. It just takes a while, and it's a pretty cool t-shirt though. And I asked for who's coding Java, right, or who's doing Java, because I'm doing for, I guess by now it's 12 or 13 years. I actually stopped counting. And I think it's like the best thing, but normally whenever I do something, it is performance related, it is garbage collection related. It is my personal favorite benchmark fairy tales. Who actually believes that NVIDIA is faster than AMD, or AMD is faster than NVIDIA? Right? You see the point, right? Benchmark fairy tales, very good thing. And I just recently started to call myself that, because I drink and I know things, at least sometimes, right? So, let's get to the point. Oh, by the way, I got some water here. Okay, so, stateless, right? So what is stateless? I tried to figure it out. As I said, the slide deck just was finished yesterday. So that was the first thing that came up on Google. It said, a person not recognized as a citizen of any country. No. So you search a little bit further, and then there is a very nice description. And it says, in informatics, a system or protocol not stores any status information. I think that sounds about right. I had this kind of feeling like, finally, I get it. And that was the thing that came to my mind. Schrodinger's cat. You guys know that, right? There is no state until you open the box, because you have no idea what happens. Okay, fair enough. So that's stateless, I guess. So who still thinks we can do stateless microservices? Okay, still a couple of people. We're not at the end yet. So let's do some experiments. And let's start simple and mean. Right? Simple. TCP. Who still thinks we can do stateless microservices? Okay, so what does TCP actually mean? Well, we have automatic error correction. We have a great fit for request response. You figure out the pattern, right? We have in-order arrival of packets. We have automatic redelivery. What does all that mean? We need to store state information. If you like it or not, there is state. And that is just the first point, right? So, is there any chance to fix TCP? First of all, no. First of all, no. But you're not working for Google, right? Because Google is working on QUIC. And who heard about QUIC so far? Some people. The others have no idea what QUIC means, right? QUIC is the Quick UDP Internet Connection, pronounced QUIC. It is an experimental transport layer network protocol designed by Jim Roskin at Google, initially implemented in 2012 and announced publicly in 2013 as an experimentation broad-ended. So, what do you think? How many people use QUIC these days? Just like, do you think you use it?
Yes.
Okay, when do you use it?
When I use Google.
When you use Chrome and any kind of Google service, especially YouTube. When you open YouTube, your video streaming actually uses QUIC. And QUIC is a UDP protocol. It doesn't have state information. It doesn't have a persistent connection for a very valid, interesting reason. Or the idea behind it is we're going to a mobile internet world. Well, we're already there, right? The mobile internet won't go away. But what happens with mobile internet is that the connection actually has to be handed over all the time from one mobile station to the another one. Or in other countries like Africa, you can't actually do persistent connections because the internet is very unreliable. So the way QUIC solves that is they have some kind of connection identifier, and it doesn't matter if they do a handover or if the connection shortly breaks down, they still can recognize, oh, we had this connection before, and they just start over where they actually ended off. And the other interesting thing here is about QUIC, they added a lot of the ideas that they actually had with Speedy, or what we call these days HTTP2. I mean, let's eliminate the actual changes of the protocol, because there's not a lot of stuff, right? You can pretty much do the changes between HTTP and HTTP2 and Speedy in like 2 sentences. Streaming is one of the important things they have. It fully multiplexed. It is encrypted by design. It is very interesting. And I've seen a couple of IoT devices already implementing QUIC to communicate with the cloud. As long as you kind of block QUIC in your firewall, then it talks plain HTTP, which is not a good idea. Right? So, are we there yet? And you will get this joke a couple of times. No, we're not. So let's get a little bit more serious, right? TCP is like, well, yeah, whatever. Okay, we're all about encryption, right? What does encryption mean? Who wants to answer that? What does encryption mean? We have to have state because we have a persistent connection. We have session keys. We actually encrypt data based on a session, and a session is state, if you like it or not. Okay, so I already said that. Why do we do encryption? Well, first of all, we want to have the privacy kind of thing, right? And I think this is, so I put this specifically before security for a very important reason. If we look at the recent past, I think privacy became a way more important point of encryption than the actual kind of encrypting security itself, right? If we look at how many pages were hacked over the last time, and obviously you can't fix that with TLS, but with better ways to store data, better password hashing functions, better encryption. But we still need to encrypt it somehow on the way to the server, right? So I think privacy and security are very, very important. And as I said, these days I would put privacy over security itself, which is probably an interesting thing. And I guess we don't need to talk about that a lot, right? So that's easy. I think, is there anyone that disagrees that HTTPS actually needs states to operate? I don't think so. So can we fix that? Who thinks we can fix that? Go ahead, say something.
We can fix it, yeah.
Oh, we can fix it, okay. An idea how to fix it?
Maybe, I don't know, maybe with some kind of identifier, some word like...
Well, we already fix it a little bit easier. What we normally do is we do offloading. That means you have some kind of TSL endpoint, TLS endpoint somewhere in the front, and, well, you do unencrypted stuff inside of a network. So if you have like the mean administrator, right, the admin from hell, or whatever, net operator from hell, that was the original term, the operator from hell, the information is still not secure. Some other people do something like SSL termination, which is kind of the same thing, but often it means you terminate the external SSL on this offloader and you encrypt it again. But this just leads to another problem. You actually have an encryption hole because you decrypt it and you encrypt it again. That means at least on this machine, you actually can access the data if you ask the memory, if you dump the memory. So, can we really fix that? Well, offloading is some kind of fixing. I don't think so. It's just like moving state, right? So, are we there yet? What do you think? Is there more? Yes, it is. And I get it. I start playing mean. So let's go with authorization and authentication. Right? We're just getting from one mean topic to the other. So why do we do authentication or authorization? Access restrictions, right? Simple thing. Nobody would argue with that. Is there anyone who thinks access restrictions are a stupid idea? We don't need those things today? Probably not, right? System security, I think a very valid point as well. Often isolation, and I'm not sure, are you guys familiar with the term multi-tenancy? Kind of, okay. So multi-tenancy means you have the same system, but you have multiple kind of tenants, like customers in the same system, and you obviously have to isolate them, right? So in this case, you definitely have to have some kind of authorization because you need to make sure that customer A can't access information from customer B. So, pretty big problem. Privacy again, this time not too big because we already encrypted things. And any kind of rolling system or roles. So not only customers, but also users inside of this customer or inside of your organization itself, right? I think not everybody at AutoScout 24 is supposed to actually change car prices. Are you? Can I just call somebody and ask like, hey, I like this car, can you make it like $20?
Hopefully not.
Hopefully not. Oh, you implement stateless microservices, right? So it should be possible. Nah, just playing mean. So, we can definitely fix that. Don't you think so? And we kind of already had this idea. Offloading. So we're going from gateway services. Who heard this term gateway service before in combination with microservices, right? So it becomes like the general term for everything that doesn't work otherwise. It's like, oh, we just need a gateway service. Okay. Single sign-on is another option. JSON Web Token is just yet another option. The problem is we move state somewhere else all the time. We're not actually going stateless. It just means moving state to somebody else who has to take care of. So there's at least one service in your system, and if you use SSL offloading, there's at least two services in your system that actually have state. It's probably not your microservice. Fair enough. You just add a lot of network hops. So, who knows that movie, by the way? I hope you do, right? It's a little bit older, but I really loved it when I was young. The Griswolds, and at least the term in Germany. Yeah, something like that. So, do we see a pattern? and I think I'm still way too fast, so we have a lot of time for some discussion afterwards. So do we see a pattern here? Yes, we do. Because we're going from one thing which is mean to the other. So, rate limiting. I guess you guys are familiar with that. Who actually tried to implement something against any kind of public REST API like GitHub or Google or anything else? Okay, a couple of people. Who hit the rate limit? Fair enough. Me too. I actually dumped our whole GitHub repository notifications and events and stuff to actually run some analytics afterwards, and it took me about 3 days because of the rate limiting. Very important feature. It's actually very nicely implemented though. Okay, so why do we do that? I think first and foremost, it's not for GitHub, but for a lot of our companies. You normally pay for some kind of quota, and your quota is often limited by the amount of money you pay, right? There are different types of accounts, and one account can have 1,000 requests per minute or per day, and the other one can have 100,000, whatever. Those kinds of things. Well, I think that's probably the most valid use case, except that there are a couple of other ones. You want to have your system not overused, right? So imagine the most common thing like a system overload. This is one kind of overuse. And probably the most important one, and that is like the one that everybody tries to prevent, it is DDoS. Imagine you don't have rate limiting and you just let everyone call as many times as he can, and then you have like a good IoT world. I'm not sure if you already heard this term, like the internet of DDoS things. That's about what we end up with, right? The Internet of DDoS things, I think that was the term. There was a slightly different one as well about, what was the thing that came up like last week or 2 weeks ago? What? Yeah, this encrypting file, make me pay Bitcoin. Right. So there was one guy on Twitter that actually made this nice picture, like having a kitchen, and the coffee machine said, oh, by the way, pay me a Bitcoin or don't brew coffee anymore. Or the oven said, oh, I let your bread be right if you pay me like $100, right? So the more hardware or the more computer systems we have, and it's pretty scary. All those things are computers these days. Full-blown computers with ARM CPUs, the more likely it becomes that they are actually misused at some point for a DDoS attack. You probably heard about the Samsung television hack a couple of months ago. I think it was for CCC, or whatever, it's like Chaos Computer Club. They actually hacked the Samsung TV, smart TV, sorry, the Samsung smart TV, obviously. Because it's smart, it can be used for DDoS. That's what smart these days means. It has more functions than the vendor actually expected, right? So that's definitely smart. That's pretty much what Google came up with, this AI algorithm that tried to translate sentences from one language to another, and nobody understands how this AI does it. Very good thing. So that is smart. But so the smart TV was actually hacked. It was a very simple bug in the Flash interpreter that was built into the Samsung television. Cool, Flash. Thankfully, that goes away, right? Browsers started to actually block that. But they could actually run code on it that ran at system level, at root level, because all of those systems have Linux anyways, right? And they could use the camera. So all these Samsung smart TVs have a camera that kind of reacts to everything, and especially can change the lighting of the picture based on the environment light, and a couple of other things like activating a microphone. And you would be surprised what those systems have in hardware. It's kind of weird. I never knew that my television actually needs a microphone. except I have like a Google TV on, or an Apple TV on it, or Siri. Like, hey Siri, I really want you to take my picture with my Samsung TV. It doesn't work yet. Give them some time. They will make it happen. I'm pretty sure Google Home can do that right now. So, back to the meaning points, right? So, what do we do about, I see I copied the wrong slide. It doesn't say rate limiting, it says TCP/IP. So what can we do about rate limiting? Well, you guessed it. We have a gateway service, and that will come up a couple of times right now. We just built an intranet service. We don't care for the world. I think that's a valid point. For intranet service, you probably don't need rate limiting. Probably. It's not like, I only use it internally and like there's just like 100,000 different microservices and I'm pretty sure all behave well. I'm not sure who has more than one microservice in production. Okay. Do you think that your colleagues all have like this well-behaving systems that never actually crash or do anything wrong? Well, you probably still need rate limiting, right? And that is my favorite one. You just ask for problems. So designing a microservice without rate limiting is like, from my perspective, like the worst idea ever, even in an internet infrastructure. And you guys can definitely say, no, we totally don't agree with that. But so far, nobody did. I'm scared. I actually expected you guys to boo me off the stage and, well, if there would be like a real stage, to kick me off and like beat me to death or something. Okay. Doesn't seem like too bad. So I have to change the slide deck for the next time and make it even more mean, I see. So, are we there yet? What do you think? Nah. It just goes on and on, right? This guy's so bad. He's just talking bullshit in front of us, and we are supposed to laugh all the time. Caches. So, who uses... Very nice. That needs a little bit of water. So, who uses caching in its microservices? I hope it's more than just those three guys, 4. I hope it's a little bit more. You understand that the concept of microservice normally has like a TCP, HTTP, whatever JSON kind of connection in between. And this adds a network hop, serialization, latency, TCP slow start. Should I go on? I hope you all use caches instead of your microservice, wherever it is meaningful at least. So, and that is probably the one that everybody uses, even though you probably don't know about that. You guys know what ETAG means, right? ETAG is the caching for web servers. Well, that is supposed to be the standard for web servers at least. So the web server creates a fingerprint, sends it together with a resource, and the next time the browser wants to request this resource, he sends the ETAG back. The server says, oh, by the way, this file doesn't change or didn't change in the past, so just use whatever you think you know about it. So ETAGs are actually pretty nice. But at least at web server level, it means you have state. So if you, build a microservice in PHP, and I heard there are some people doing that, even though I wouldn't recommend it, but that's a different thing, right? I heard there are people writing microservices in JavaScript. Who am I to argue? So as long as your microservice runs in the web server, this thing becomes a state of your microservice itself. And as I said, PHP, as long as you don't use CGI, and I think this is a thing of the past. Is there anyone still using CGI these days? I don't think so, right? Who knows what CGI still means? Okay. Who's under 30 and knows what CGI means? Okay. We had this question at DevOps with a little bit different thing. Let's see. Let's just try it. Who knows the Java Posse? Java Posse. There was a podcast, okay, one person. Okay, the joke doesn't work here. So at that point, like 90% of the rooms had their hands up, and then they added the next question, who's under 30 and knows the Java policy? And it's like 2 or 3 people laughed, and like, okay, how do you create a question to make 90% of the room feel old? Right? This is like a challenge. Okay, so the second thing, database caching. And I hope this actually is something that more people use, even in microservices. Who uses databases underneath the microservice? Okay. Who uses caching in between? Still just a couple of people. Hibernate, or anything that works like Hibernate, second level cache. Did you ever heard of that? So you probably have some caching you don't know about, okay? And my personal interesting feature, and I'm coming from Hazelcast, and we're being used a lot of as a cache between everything, right? Between left and right, between microservices, between database and caches, between databases and databases. I've seen pretty much everything. So that is actually my favorite one, caching between microservices. And this actually makes sense if you have microservices and you say, well, the result is valid for the next 5 minutes. That's perfectly fine for me. Like for AutoScout 24, it could be, hey, please give me the prices for this result set. Or a different example, let's take Trivago, because I'm not sure how the system works, right? So Trivago actually says, well, please calculate all the prices for Rome between, what is it today, the 23rd and the 24th on hotel rooms. Pretty simple example, right? The interesting thing is, there is not just one person to ask for those prices, but there are probably more, right? So you can actually cache this result that comes from anywhere else in your infrastructure and say, hey, I guess this might be okay for the next like 5-10 minutes. And the way it works is when the customer actually clicks on a link and says, hey, I'm interested in that very hotel, they ask the backend system again, okay, now please give me the current price list, right, for this very hotel.
That's 3 times as much.
Right. So the interesting thing here is that there is a very high chance that a lot of people ask for the same thing, especially if there's a conference. Normally people stay the same days or the same time frame. And for Trivago, at least, as being a meta search, it means they have to ask not only internal infrastructure, but a lot of external microservices as well. So they use a lot of caching in between. And I think that is like an obvious, more like general statement. Whenever you have something which takes a long time, you try to cache in between to actually go around this, whatever, response time, calculation, whatever it is, right? So caching, and I said I hope that more of you guys actually use caching and you probably don't know about it, which is okay. So can we fix that? Yes. We're going back to the same topics over and over again, right? We can offload it. So, for example, with Hazelcast, you could start up a separate cluster, store your information, store your state, and just access it through a client, right? Right, Hazelcast, there are other options. I have to say it at least twice in any kind of session. Otherwise, I'm being kicked off of stage by my CEO. Well, so offloading. Can we fix it any other way? I don't know. Maybe I haven't figured out it yet. Any idea how we fix that in a way that it actually doesn't really affect our microservice?
Being fast enough. Being fast enough,
okay, fair enough. Having external systems, having other teams, do you control being fast enough? No, right? I agree. If we don't have this problem, I'm definitely not for pre-measure optimization. If you don't have this problem, that's fair enough. And just say I don't need it. But you will come back to this point later on at some time, at least. And who knows that movie? Eurotrip, right. Isn't it one of the best movies ever? I loved it. And it's not because of her, right? It's because of him, obviously. Okay. And let's break some state. Right? We're talking about stateless all the time, so let's finally break some state. Circuit breakers. Do you guys know how circuit breakers work? We have some state that says the backend service, whatever it is, database, whatever, is cool. We can use it. And at some point, if errors arise and the number of errors actually grows, we say, well, don't try to use it right now. It's probably broken. We need to fix it. Wait at least 5 minutes before you try to contact it again. You get the point, right? That is state. We actually have to store this information. And I think circuit breakers are a very, very valid pattern in the world of microservice. And I hope that everyone uses actual circuit breakers in its own system, at least between the different backend systems. If you ask Netflix, they would probably say this is like the most important thing in your infrastructure. For people that know the Hystrix API, they would argue that probably Netflix is not right about it, because it's like the worst API I've ever seen in my life. There is a reason why everybody tries to wrap it into something nice, like Spring Boot. I actually tried to implement my own circuit breaker, and I wanted to, so a circuit breaker that works against interfaces, right? So you have an interface that defines your backend service, and you just call it like any kind of Java service. And one of my ideas was to actually back it by Hystrix. And I gave up because there's no documentation, the API is shitty, and I think except for Netflix engineers, nobody understands what is actually working or what is going on. So that's a whole topic on itself. Please create APIs that other people love and understand, at least if you want somebody to use it. Okay, so why do we do that? I guess system healthiness is like, or system health is like the most common and most obvious thing. We had the long-running requests already, right? Every time that a backend service is not reachable, we run into a timeout. So the request is not really long-running, but because we have to wait for the TCP timeout or whatever timeout happens, we have to wait, right? Maybe the system is still able enough or still working enough to actually is able to accept your request, but then nothing happens, right? There's never a response coming. And at some point you say, okay, just cut it off, I'm returning something else. But all those timeouts create this very bad feeling for users in the front end, wherever this front end resides. And this is probably the more ungeneral kind of statement for long response times. Often companies have like response time SLAs. Probably not for you. You're probably in the good state, but especially for banks, like interbanking system has often like a response time SLA. Either you respond in that amount of time, or you just leave it alone. So what happens here is that the circuit breaker normally blocks after like a maximum amount of time, and when this happens a couple of times, it will just return a default value or saying the system is not available, whatever. It actually means you have to design your system in a way that you can work with those kinds of failures, that you can work with the state of a system not being available, right? So, one more time, can we fix that? Sure. Before I actually give you a real answer, sure we can. We can just leave alone circuit breakers, but as I said in the beginning, I think that's one of the most valid patterns in microservices. So let me just be blunt. I don't think so. I don't know, but I don't think so. And I guess I found the right picture for that. Right? So I think it's the last, or maybe one or two more. I don't know. I don't remember. I just created yesterday, but I don't really remember anymore. Too much beer in the afternoon. So repeatability. You know what repeatability is also called? idempotency. You guys know what that means, right? You can execute the same call over and over again, and it will end up in the same result. So I have this like real repeatability. But to do that, or not to do that, but we want it because we already said that systems might be unreliable. They might crash for the first try, maybe we retry and it works in the second time, right? But it means we have to have some state to actually figure out, first of all, the request failed and we need to retry. That means at least for that amount of time, we need to hold the original request to actually retry it. But it also means that the system needs to have some kind of unique ID for each and every request, something which is some kind of state as well, because we need to calculate those unique IDs. Yeah, you could use UIDs, I know. But it means on the other side, and now we're switching away from your microservice again a little bit, because the other side actually needs to keep some kind of, and I'm not saying the word transaction, you know what it means, some kind of mechanism to roll back the actual request that failed intermediately, right? And I'm definitely not saying transaction, please don't do that. Transactions are not the way to go these days, even though it's still the easiest way in Java EE service. That actually means we need some kind of idempotent requests. I guess you guys see that this is itself a problem, right? Can we fix that? If we have this kind of problem, and I guess it happens more and more often these days, because systems getting more and more independent from each other, so we probably have this problem thing. No, I don't think so. So we already had like 2 or 3 things that either are not fixable, because I know they're not, otherwise, or I just ignore that there is something, or that are not fixable even by offloading them to a gateway. So, now it's the last one. Now it's the last one, I promise. And who can guess what that is? Going with the flow. There's one big topic left that we didn't talk about yet. And I see you guys are like already sleeping like, oh, this guy is so boring. Event streaming. Event streaming, you know what that means, right? A decreasing load, normally used with Websockets. Is there something better than Websockets? Zero MQ. Okay? Well, I'm still talking about web services or web applications. Long polling, you could argue that is better or not. So you could do HTTP streaming or HTTPS streaming. Both ways are very interesting. HTTP2 streaming is something I guess I created because it's officially not exist. What I did is I just opened, so you know that HTTP2 is multiplexing, right? You can have multiple channels all being sent at the same time, and it just does some framing. So what I actually did is I opened the stream and I never closed it. I'm just pushing data, keep pushing, keep pushing. Works pretty well. I'm not sure if it works with browsers though. I implemented my own client. But HTTPS streaming is a very interesting thing that is going around for a long time, and the most common implementation for HTTP streaming, or HTTPS streaming, or SSL streaming, any idea? OpenVPN. OpenVPN, I heard it. I heard it. But there's one more thing that we can do, and that is like, if you ask like a front-end JavaScript developer, any kind of front-end JavaScript developer, you should shout it at me right now. No? Ever heard of server-side events? Right? The cooler WebSocket if you don't need like TCP plain, or if you need binary packets. So server-side events is like you register yourself for to this topic. So you can imagine as some kind of pub/sub implementation. So you register yourself to a topic and you're automatically being pushed the events. So all of those things, no matter what it is, they all mean you have state. WebSocket, definitely have connection state, because it's a TCP connection again. Long polling, at least it's the TCP connection, but long polling means I send the request, and the server actually holds this request until there's data to be sent back. So obviously we have connection state, not only in TCP, but also in my application. HTTP, HTTPS streaming, at least the connection state and session because both are encrypted. And server-side events, well, as I said, it pops up, so I need to I need to store the registration somewhere. The good thing is, for a lot of these problems, the server actually hides it from you. So your application or your microservice still looks like completely stateless. So, as I said, this is the last one. For the final time, can we fix that? No. And I said 40 minutes, and I'm pretty good in time. So, are we there yet? Yes, we are. Yay! So, how do we build stateless microservices? We ignore their state, which is easy. That's probably the easiest way to do. We move state somewhere else, which is definitely clever. Right? Gateway services. Or we don't even realize there is state. And that is something like, ooh. Right? So that are the three ways that I can come up with, or can come up with, how to implement stateless microservices. And I said this is going to be a meet talk. So I all hope you're like, oh, thanks, it's over right now. Whew. So, and now I'm looking forward to discussions. And I hope I'm wrong, and I hope you guys have better ideas how to do that. So excuse me for being wrong right now. But I hope I demoralized you enough to get some discussion like, this guy is so wrong. So, questions?
Random org?
Sorry?
What about random org?
Random?
Random org, like, is it a good enough microservice that generates random?
Oh, okay. So just sending information from def random, or let's take def urandom to be definitely on the good side, right? Yes, I think that is probably good enough, but you still have the file handle, which is at least state.
You need the seed.
What?
You need the seed to start off with.
Right, but you could just push those information using UDP. But you have a file handle in the worst case. There's always something I can come up with where there is actual state, if it makes sense or not, right? I'm not saying I'm right here. I'm just saying there is state everywhere. So I could do the same thing for serverless, which I think is like the worst term for anything ever. Right after JavaScript. You see, I love JavaScript, right? You get that, okay. So anything else? I said we're gonna do a discussion here. I don't want to say like another 19 minutes, so 18 minutes. Just looking at you, give me some work to do. Give me something to explain.
Okay, so why isn't it trivial? Because we're all descended from a.
It's on.
Is it on? Yeah.
Yep.
So why isn't it trivial? We all, are descended from one-celled organisms, and that's why we all have nucleus. And nucleus is, susceptible to whatever attacks or. So isn't state something that should not even be considered, a problem?
A thing? Okay.
Yeah.
Well, I guess you can ask the same question for nullability. Right? Is there anything like null in the world? No, but we still created this concept. And can you imagine, well, except for functional programming, can you imagine any kind of software not having null fields? Probably not. I don't know why it is hard. To be honest, I don't know. Why it is hard to build a system with no null values at all. It is extremely hard. You can do it. And I'm pretty sure you can somehow create a completely stateless microsystem or microservice system. The question is, does it serve any purpose?
Yeah, why would you want to have one? A side effect-free software. It's uninteresting. State-free. Maybe uninteresting as well.
Okay, so the claim is that side effect-free software is uninteresting. I would definitely argue that one, because it means if you have side effects, you can never actually rerun anything, and it's not that easy to scale it out.
No, I'm talking about the high level. So like,
high level is easy.
Once you request something from a side effect-free software, you change your own state. That means it's a side effect. That's what I'm...
Well, that's what is going to, you have to roll back the state somehow if the request actually fails, right? Yeah, I don't know why it is hard. I'm just saying it is hard, and I can't imagine a way to do it. And as I said, I hope I'm actually wrong.
Isn't the idea of a stateless microservice or service that you actually push some of the state up and some of the state
right
to have your stateless microservice in between, and those few...
There you go.
Yes. So quoting the clever part in there, which is actually one of the practices you should use. And those kind of states you have then is then not shared state across the instances of a microservice, but isolated to one of those microservices. So if this state goes down, if you start a new instance of the microservice, you don't actually bother. So it's not shared state. And
sure.
From the notion, from an architecture perspective, it's still a stateless microservice, because if it's gone and the connection sitting on top of this service is gone, and you start a new one.
I agree. And I would consider that a workaround. That's normally in software what we do as workarounds. We move the problem somewhere else.
Which, of course, I agree.
So I had two remarks.
Okay.
The one thing about the nullness I cannot leave unanswered.
Fair enough. Go ahead.
You know the inventor of nulls?
Yep.
Who's that?
I don't remember his name, but yeah.
Sir Tony Hoare.
And he said it's the worst idea he ever had.
It's the billion-dollar mistake he made, and he apologizes on every talk that he invented nulls.
Yep, I know.
I met him, and I had...
He apologized personally, like, I'm so sorry you have to work with it.
Yeah, absolutely.
Well, this poor guy has a lot of work to do.
Yeah, he has, and he caused a lot of says he caused a lot of costs due to his silly idea of nulls. So yeah, there are different perspectives on the nullness issue. Some consider it essential, some consider it a bad idea, some consider it accidental complexity. Sometimes it's a necessity to use.
I would consider it a bad idea. But I guess in most applications, especially when you start using schemaless systems, null is like a necessary evil, unfortunately. Probably all these schemaless systems are wrong so far, I don't know. But if you use something like XML or JSON, you have to handle null somehow.
Yeah, I don't want to go into too much depth on that.
Okay, fair enough.
From functional programming side, you can go around having nulls by using proper types.
Yep.
The other thing about state, I would go along Christian's remark as well. I think the notion of state you presented is very nitpicky in a way and very narrow, saying, okay, everything that I have to keep in memory is state.
Very good. I love that. That was exactly what it was supposed to be.
I'm not sure it's a meaningful definition of state for talking about stateful or stateless microservices, because the thing about state, as Christian said, is that you can't not ignore the state. You can rebuild state very cheaply. Sometimes you do it properly, and then that state that you can rebuild without high costs is actually something that you do not really have to consider as state.
Okay.
So for
fair
example,
enough,
for an SSL connection, when you can rebuild trust, you can rebuild the connection cheaply, then it's not necessarily useful to consider it as state. For other things that are a bit more expensive to rebuild, like database, customer data, it's more meaningful to consider this as state.
As I said, not everything in this stack is definitely like a meaningful idea of state. It was more like to exactly be that, like kind of picky, to actually prove the point that there is nothing like. So no, let's start from a different point. I'm normally having a big problem with those terms. As I said, serverless. I think serverless is like the worst ever term created. Stateless is kind of the same thing. There is state. So stateless is the wrong term. I don't know what we better call it, but stateless is the wrong term, and that was pretty much what I wanted to show here.
When you have a very narrow definition of state, it is, yes. Same as for serverless. The concept is interesting, but the name is maybe not the best, that's for sure.
Same goes for microservices.
Same goes for microservices.
I actually like the term microfunction for Lambda, because I think microfunction is probably the better thing. I'm waiting for the last patch being deployed on Lambda and being sold.
Serverless does not mean Lambda function.
I know, but it's like one thing.
And just to say one thing, because of course I have also my special, say, flavor to statefulness and statelessness. So at AutoScout, we externalize state where possible. We rebuild state where it's cheap. And actually you can, with an immutable infrastructure and kind of stateless stuff, you can also host Kafka. So what I did with Kafka, externalize all the state, let AWS or your cloud provider deal with the state. So don't solve that hard problems, let other people solve it. Same with API gateways or stuff.
Which basically goes back to, I said you can build stateless microservices, you move the state somewhere else.
Exactly.
Which is probably the only way to actually do it.
Thank you very much.
Ich glaube, er meldet sich schon länger. Ja, ich glaube.
Okay, so one bad thing about state is that you cannot scale horizontally. So like you cannot put another server on another server, but when you don't have a problem, actually doesn't matter. And sometimes you can move a state to another service, like have a database server dealing with session, have a EM cache, have a Hazelcast cache.
There you go.
I've heard good things about it.
I guess nobody of you will try Hazelcast just because of this very bad slide deck.
Yeah, actually, the point is actually when you want to scale up, then you don't want to have state if you want to scale horizontally. So if you want to buy bigger servers, in the other cases, it doesn't matter at all. You can have state. Who cares about state? If a software handles it, it's easy.
That's what a lot of people do with Hazelcast, for example. They use web session clustering, and they actually move the session state to a Hazelcast cluster. Right? It is the same idea of moving state to an external system.
So
the
you're carving up your problem into two problems. One is the problem of state, you put it somewhere, and then you have an additional problem, which is less of a problem, the stateless server sitting on top or below the state.
So let's agree on one sentence in the slide deck. The solution is to move
the state somewhere else. So either pick the vendor of your choice and let him handle the state, push it up to the client so that your server doesn't have to handle the state, JOT tokens or whatever you mentioned there.
State isn't a problem. State is only a problem when you have to scale. If you don't have to scale or have a need for that.
Okay. State is only a problem
as soon as you're distributed, you have a problem with state. So whether you need to scale or not.
Okay. So let me quickly answer that. So he said that state is only a problem when you have to scale. Who creates a system that doesn't need to scale anymore? Oh, wow. Okay. There are two, somewhere else? Two people. Right? Fair enough. If you don't have to scale, that's a valid point. Most systems these days don't have this, like, easy of life.
If you're a Google or Amazon, you can scale easily or vertically. You can also do a lot of cool stuff with simpler.
Okay.
I want to...
Love to talk about that later. Yep.
I want only to raise a question. Is stateless somehow linked with evil? Because we... because...
Now it is. Yeah. I just made it evil. Now it is.
80% of... We talked about authentication, authorization, rate limiting. I think there is a pattern here. I don't know. We are protecting all evil here. If we abstract out evil, maybe we can build serverless microservices.
That sounds like a good idea. We should try that. Where do we start? But yeah, that's a very valid point. Most of the state is to actually prevent ourselves from any kind of evil. So if we could somehow build this out of the, well, world, I don't know, right? That's a valid point. Never thought about it that way. It's interesting. I think we can finish now. People start to leave. Now definitely is the point like, come on, get out here.
Is there a meta question? Is there a Hazelcast pitch in there somewhere so
No.
that we
No.
Is there the option of a Hazelcast pitch? So now we heard why stateless could be associated with evil, and the audience is arguing no, it's actually not evil and it's a valid design pattern, and we all agree that state needs to go somewhere if you want to have the advantage of you yourself want to building only stateless services. So there could be a place where state could live. And do you have a potential answer or anything that could help us out of this dilemma? Where should be state?
I try to prevent doing that. Okay.
No, I'm asking you. I'm asking you if there is any interest, because personally, I see Hazelcast in there. I believe for some of the people attending to this evening, I had the notion that there is at least not potentially a sales pitch, but at least a quick glance into what Hazelcast could provide as an answer to that, so that we are not completely missing out that part of an opportunity.
Okay, so all the non-Java developers are gone yet, right? Oh yeah, sorry. Well, you get that, right?
So any interest
just imagine a very bad C# or something.
Yeah.
And you get the idea. I can use Kotlin if you like. I could use Kotlin if you like to.
So I'm just asking the audience or who is left of the audience, who would be interested in knowing a little bit more about Hazelcast, the stateless, stateful dilemma you raised.
Let's do the 5 minute. Let's do the 5 minute very quick demo.
Okay.
So everybody has something to see.
Just very quick. It's not really a question.
Huh?
You gave a fantastic speech. Will you just take a couple of seconds to actually appreciate
Thank you. Okay, I'm not sure if you guys can read that actually. So let's see if we can make it a little bit bigger. Yeah, that should work. So 5 minutes Hazelcast. I already said Hazelcast is a distributed system, right? You can actually store information in it. There are a couple of things about Hazelcast which are very nice and unique, I guess. My personal favorite, so I started using Hazelcast when I worked at Ubisoft. I actually introduced it at Ubisoft, and you see I'm a big fan. I ended up at the company, right? So one thing for me, and I said Ubisoft, these guys are normally using C++, working on handhelds and computers. They had no idea about cluster technology. My first day I started, or on the first day when I started, I asked them, okay, you have a game world, and the game world consists of multiple game servers. Kind of obvious, otherwise it wouldn't be a world, right? So what is your cluster technology? And they were like, cluster? What do you mean? Yeah, the servers have to communicate somehow, right? Oh, you mean how we exchange information? Oh, that's easy. There's a database table, and everybody's writing data, and the other ones are just polling. MySQL, though. Right, so, okay, I had this feeling like, okay, this won't work out forever, so we need to find something. And I read about Hazelcast somewhere in, I think, Java Magazine, something like that. I wanted to try it for a while, and I got back home like after the first week of work, right? And I had this feeling like, okay, you need to fix that. So, okay, let's try to find something which probably works better. So let's try Hazelcast. So Hazelcast starts with the Hazelcast instance. That is like the entry point into the world. And that is pretty much the only thing you need to know about Hazelcast, except that, okay, let's create a new Hazelcast instance, and there we are. That's everything you need for a cluster. I can start that, and it literally creates me a cluster. Compiler, go on. So there you go, a one-node cluster. One-node cluster. It doesn't make really sense, right? That itself is an oxymoron, so let's start it a second time. And it connects after a while. And there we go. This auto-scrolling. And there we go, two nodes. I could do this like 100 times. By default, it will use multicast. Here, I did some trick. I actually have, where is it? There you go. I actually have multicast disabled, but TCP IP bound to my local interface because I had it once at a conference. But I was on stage and someone was so like eager and engaged, he actually coded everything live on his own laptop, and guess what? Multicast figured out he's starting nodes. Right? Not a good idea. So I started to have that all the time. So, okay, now we have a Hazelcast node. Let's comment that out for a minute, and let's write some meaningful Java code, like a random number generator. We're generating like 1,000 very, very random numbers, and we need to store them somewhere, and that is, so let me see, I'm not sure. That is a Java util map, something we all know, I guess. Integer string, we create a map, and yes, import Java util map. And normally you would say hash map or concurrent hash map, right? And you put it in like I, value, I, something like that. I guess that even works for JavaScript developers or, sorry, C# developers. It's much better. So for the C# developer, a map is like a dictionary. I'm not being mean here. Okay, so now we have like a simple Java code, right? So here's the interesting point. We change one line of code, and we say, Hazelcast, please give me a map, and we call it Munich, because I like Munich. And the rest of the code stays the same. And that is the beauty of Hazelcast. And I think that is all I want to do for today. This is like the 5-minute pitch. Hazelcast uses the common Java interfaces. If you use the C# client, it will use the common C# interfaces. If you use the JavaScript client, it will use promises and all these kind of JavaScript features. If you use Python client, it will use the Python stuff. We try to make Hazelcast as common or as logical for developers as possible. So if you look at most of the other distribution systems, they normally tend to have their own APIs, and it always seems like they try to make it as hard as possible so they can sell some consulting. We stick to the standard interfaces and make it as easy as possible. I often say that we try to make it, or our purpose in life, like from a project perspective, is to prove that distributed computing doesn't need to be hard. And well, let's do one more thing quickly. So what actually comes out is an IMAP, and IMAP has some more features, like IMAP is a concurrent map, so you get all the concurrent functions, like compare and replace and put if append and those kinds of things. And IMAP adds additional functions which are cool for whatever, distribution, right? So you could, for example, do, so I think you guys know that, right? Map values. But what you could do with Hazelcast, for example, is predicates, and so imagine you would have something like a user class equals user ID 10. Let's put it down here. And you figured out I haven't created anything up front, so age 15, well, let's make this greater equal, something like that. And you can pass, whoops, we obviously need to store that. And you can pass that. And what it will do is Hazelcast internally distributes the information. So if you have like 3 nodes, each of the node will keep 1/3 of the subset. That is how we create the speed of Hazelcast. And the client still knows or can still figure out before he sends a request which node will hold this information. So every request in Hazelcast is literally like a one-hop network operation. And in this case, we take the query and you can guess or imagine it as some kind of a map-reduce operation, the easy fashion. We send it to every node, and because data is partitioned, we know there is no overlap. So everyone just works on his local subset, returns the matching result or the matching entries, and we just merge them together on the client and say, here's your result. And there's a couple of more things, there's listeners and all that stuff, but that was not meant to be a Hazelcast pitch, so I'm sorry.
So this is...
This is then where the state should go into your Hazelcast distributed.
It could be, yeah. We have a lot of people, especially in the microservice area, doing that, especially for things like caching, as I said earlier. Well, interestingly enough, and that is probably something interesting, I'm not sure I agree or disagree with that. I think there are like 2 very different or very distinct things for microservices to do. So there is one group of people saying that everything needs completely isolated up to the database. And the other person says, well, I have a big, huge IBM, Oracle, whatever database, and I'm not going to pay for it 100 times because I have 100 different microservices. In this group of people, an Oracle database will never work out. They normally use things like Postgres, MySQL, whatever, those kinds of things. I'm not sure, that's an interesting question. What is your take on it? Is there like a hardcore separation, isolation between everything, or would you say like a common database layer is like feasible, meaningful, whatever? Or do you think it's more like a business decision? I mean, should be a business decision dictate what we do with our architecture?
So in other words, should microservices share a database?
Should they be allowed to? I mean, from a business point of view, it is probably like meaningful to have a big Oracle database because most companies probably have them already.
Database or database server?
Database server. Let's say database server. It is still like a single resource, whatever.
We're not talking one schema, right? We're not talking one schema, we're talking...
No, yeah. Not schema, right.
Anybody agrees with that one? So should this be allowed? Yeah, so I want to hear your opinion.
As I said, I'm kind of, I don't know. I actually don't know if I would say this is like meaningful or not.
Yeah, I personally think that you have to separate the things. One is the logical view, which is separated to the different schemas, and one is like not hardware, but the service, the process that is providing this stuff. And I think that there are reasons, especially business reasons, as you mentioned, that make it really a sensible or a good thing to use the same server for this thing.
But each microservice should have its own schema then?
Yeah, of course. I mean, from a logical point of view, they should be separated. It's just that the actually piece of code, the software that actually provides the database is the same. And I think that's fine.
So next question. Keep the microphone. Keep the microphone. Next question. Should or is it then okay to have like a huge Hazelcast cluster which isolates clients based on permissions? Because that is the next question, and a lot of people say, yeah, we have this big Oracle database, but caches should be separated. And that's just for my own interest. This is like nothing, you guys don't need to listen.
I don't know. I think that's also, you have to see the point of like if it's logically separated or not.
You create multiple maps and you separate by permissions. Which is probably what you're talking, well, what somebody's talking about, like having different schemas, which is like different maps. And the database just uses permission isolation to actually separate those.
Yeah, well, I think if you
you don't need to answer. It's just thought you probably can say yes or no.
I can give my thoughts on that.
Sure.
I would stick with the same answer there. I mean, if you like have, if I have one microservice that puts a map in there with like key A and the other one uses key B, and they don't interfere with each other, then I think probably it will be fine.
So what I mean is you would have like microservice 1 has its own map, and microservice 2 and microservice 3, and they all have like completely independent schemas. Yep.
Yeah. One remark on this. It goes to both the database and the Hazelcast. I mean, we have two levels of interaction. You have the logical interaction on one side, and also you have the resource level interaction. So if quotas are implemented correctly, you can probably get it to work properly, but you have to be aware that you share CPU, memory, disk I/O resources as well, if you use the same physical infrastructure.
But aren't you doing that anyway? I mean, nobody will have like a proper hardware for every microservice that he has. You have some kind of infrastructure that does provide some virtualization where you have the same problem. You have to have these quotas and everything in place, etc.
We're finally coming to the discussion point.
So we previously talked about the notion of serverless, and serverless for me not only means Lambda function, but also having higher level managed services. So we heavily use, for example, DynamoDB. This is for me also an example of a serverless service of a, in quotes, database, and actually I don't know whether this is running on the same hardware and is just using some multi-tenancy quota or throttling for me, or whether this is my individual DynamoDB instance I'm running on. AWS doesn't tell me that. So for me it's totally fine. I have my DynamoDB, which is part.
Is it still totally fine if you run into bottlenecks and you can't figure them out because you have no idea what is happening?
If you go the managed service serverless route, you have of course SLAs and SLOs and some kind of things you're agreeing to, and the other side needs to adhere of that. This is part of the trade-off you're doing that. They are guaranteeing you some kind of service level. You have to pay for that, or you're one of the tenants using that capacity, and that's provision for you, and you hope that it's there for you. If it's not there, then it's a violation of a service level agreement. Same with quotas or throttling anyway.
Sure.
So conceptually, this is totally fine. If there is a bigger thing behind me and it's serving me, the idea that it's cross-pollinating and that it's a single thing conceptually does not bother me. The problem with Hazelcast for me would be that it's not a separate thing, but it's part of my microservice. So the distributed cluster itself is, at least in the example you gave, is something that's running
in this example, I'm running embedded. Normally, the recommended way is starting a separate Hazelcast cluster. So let me say, or let me come to the point why I brought this up. So what we often see is, as I said, we have a lot of big customers and they have like this huge Oracle databases, and obviously all the microservices share this kind of level. So what we often see is that they have like a huge Hazelcast cluster in front of the database as a cache. that is used by our microservices, separated by client IDs, by permissions. And then they start, like here, embedded Hazelcast members, or maybe if it's like a huge microservice number, they start a separate Hazelcast cluster and they use clients. So they have like a two-layer system. They use the shared state of the microservices in their own cluster, doing a fully isolated view of that. But for the database, they use like a common view.
Okay, thank you very much. I believe it's now point in time where we do a wrap.
Yep, no worries.
Be up front there, grabbing another beer and be open for further discussion. I believe we also have beer outside. I believe pizza is already gone. Thank you very much for attending and the ongoing discussion and the provocative meme with some meat afterwards in the Q&A. Thank you.
Right. One more thing. One more last thing, and that is like my own personal thing. If you're interested in anything related to JVM and you're German speaking, feel free to join this Slack. There are like 450, 460 people right now, and there's a lot of discussion, especially around Java 9, obviously at the moment, but anything else related to Kotlin, related to Jython, whatever you guys want to do. So if you're interested in that, well, the URL is simpler right now, but that URL works as well. Go to that URL, create your own invite, and feel free to join.